In our study of inverse functions, we have purposely, until now, avoided finding inverse functions algebraically because there's a lot of other things that we can do without actually worrying about the formula. But at some point, we need to worry about the formula, right? So here's how we're going to go about finding the inverse function. We're going to, often we'll see like f of x function notation, right? So we're going to just replace that with y. Then we're going to isolate x, okay? Interchange x and y, and then just instead of y, we're going to write f inverse, okay? Now, other places you might see these steps out of order, almost in the opposite order, and I get it. There is a reason for this, which will become clear as we get to our trickier examples, okay? So take this process on faith for now. Let's determine the inverse function. Okay, so let's follow these steps. Okay, step 1. Replace f of x with y. Okay, that is super tough. Whew. Okay, there we go. Number 2, we want to isolate x. So at the end, I want like it to say like x equals something, right? So what do I do to isolate x? I have to subtract 3. Okay, so subtract 3. Y minus 3 is equal to 4x. Okay, divide by 4, divide by 4. And then I get y minus 3 over 4 is equal to x. Okay. And lastly, interchange. Well, not lastly, second to lastly. So I'm going to have x minus 3 over 4 is equal to y. And then in place of y, right, in step 4, I would just write the inverse function notation. Okay, is equal to f inverse of x. Okay, there we go. Okay, and that's it. We have the inverse function. Oh, that isn't so bad. Let's do another one. Okay, so again, I write y. I'm not going to number my steps this time. I'm going to write y is equal to x minus 2 over x plus 2. Okay. Oh man, now I need to isolate x. How in the world do I do that? Well, okay, I guess I can do cross products. Okay, so y x plus 2. So I do that cross product is equal to the other cross product, x minus 2. Okay, I want it x equals, well, maybe, I guess just continue with the algebra and see what happens. Distribute, okay, xy plus 2y is equal to x minus 2. Okay, when we isolate x, that means all the x's need to be on one side and all the non-x's need to be on the other. So I'm going to subtract x from both sides, and I'm going to subtract 2y over. I'm doing 2 steps at once. If you want to break it into 2 steps, feel free. So I have xy minus x is equal to negative 2 minus 2y. Okay, x's are on one side. Oh, but wait, each term contains an x. There's a common factor of x. So pull that x out, y minus 1 equals negative 2 minus 2y. Divide, x is equal to negative 2 minus 2y over y minus 1. Okay, yay, we did it. Okay, and then sirens and balloons and everything go off because we're able to isolate x. This algebra is actually quite tricky. Okay, so take your time, ask questions if you're unsure how to proceed. So replace or interchange variables. So y is equal to negative 2 minus 2x over x minus 1. Okay, and then replace y with f inverse. Negative 2 minus 2x over x minus 1. Okay, and that would be my inverse function. Okay, there we go. Okay, yep, there's a question there for you to consider. Could you have done this mentally? The second one, probably not. That if you did that mentally, hats off to you. I can't do that mentally, so that one takes a little bit of time. The other one, maybe. All right, let's look at some of these other examples. Okay. In particular, h of x is really annoying. Okay. Let's take a look. Okay. Replace it with y. Okay, x plus 1 squared plus 2. Okay. I want to solve for x, so I need to eventually like subtract 1, square root, and subtract 2. What orders do I do those in? Well, careful order. But but we would actually need to isolate the square first, so subtract 2, okay, is equal to quantity x plus 1 squared. Okay, now I can square root, but remember, when you square root both sides, when you introduce a radical, you need the plus and minus in front of it. Okay, it's equal to x plus 1. Okay, now at this point, remember how I said inverse functions have to satisfy a one-to-one property, and if you ever have a plus and a minus, it violates that property? Well, crap, we're stuck. Here's what we need to do. We need to be able to pick the sign. So what I'm going to do is I'm going to introduce an extra condition. I'm going to say that x is going to be, I don't know, let's say it's, for fun, let's do it less than or equal to -1. Okay. Why is it that? Let me go one more step and show you. Okay. X, I move 1 over, -1 plus or minus square root of y minus 2. Okay. Introducing this extra condition will force it to be 1-to-1 because I'm thinking, okay, well, this value that I get out has to be less than or equal to -1. So that means this value has to be 0 because I already have a -1, right? So -1 plus or minus 0 would give me that -1. But then if it has to be less than -1, I need to get -2, -3, -4, whatever, right, for x, which means the only way that I can do that is if I use the minus sign, right? If I do -1 plus, I'm going to get values that are larger than -1, and it's not going to fit this criteria, okay? Now, normally, will you have to make this condition? No, I'll probably give it to you, but just so you're aware, pluses and minuses, or if you have a plus and a minus, that violates the one-to-one property, so we need to be able to pick between them, okay, using that extra condition. All right, so then at the end, we have -1 minus square root of y minus 2 is equal to x, and then again, interchange -1 minus square root of x minus 2 is equal to y, and then call this f inverse of x. Boom, there we go. All right, so this one was tricky because of the plus and minus. Let's see how this other one is tricky. Maybe it isn't, okay? Alrighty, so let's do our normal process. Y is equal to square root of x minus 3 over 4. Okay, and then I want to solve for x, right? So multiply by 4. Okay, you could actually square 2 if you wish. Square root x minus 3. Okay, and then introduce a square to get rid of the square root. Okay, 16y squared is equal to x minus 3. Add 3, 16y squared plus 3 is equal to x. Okay, and there isn't a problem in this form. Okay, as we go and interchange, 16x squared plus 3 is equal to y. And then do the inverse, 16x squared plus 3. Okay, let's see what these things look like graphically. So here are the functions, and remember they should be symmetric across the line y equals x, but they don't look very symmetric, okay? And here we might need to do a little bit more thinking as well, okay? Specifically about the domain and range, okay? If we think about the domain for the original function, let's see what that looks like. The domain is 3 off to infinity inclusive, right, for the red function, and its range would be 0 to infinity. Okay, so, okay, now I gotta write that down. Let's capture that. Okay, so the domain here is 3 to infinity, so then the range, and the range we said was 0 to infinity, okay? So then when we look at the inverse function, right, its domain should be the range, right? So the range here should be the a domain in the inverse, so 0 to infinity, and then the range should be 3 to infinity, okay? But when I look at the graph, that isn't the case. How do I make it the case? I force it, okay? So I need to say, yes, this is what I want. So I'm going to add a condition here. When x is greater than or equal to 0, I have this function, okay? When I add that condition, let's see what I get. And in Desmos, you add that condition by doing like a curly brace and then x greater than 0. Okay, now is it more plausible that they are mirrored images of one another? Yeah, yeah. And this is exactly what I want. So the takeaway of all this is, in some examples, when you have squares and square roots specifically, you need to be on the lookout for extra conditions. Make sure that you can find the inverse, but whenever you have a plus and a minus, right, make sure to select the right symbol or right sign, okay? And then also, if you have a square root given to you, that you're introducing an extra condition to make sure that you have that symmetry between the functions.